So here is our implementation of the list, and we have a constructor which does some initialization. We have created an add member function which adds a value after the last element in the list, and we have a print list member function that is going to print the list in a decent format. We have two Boolean member functions, one for checking the emptiness, which is the underflow, and the other for checking the fullness, which is the overflow. And this is the code. We added four values to the list by calling the add member function, and now we are going to implement the insert member function. So let's create our insert at member function. It's going to take two things: the value that we want to insert and the index at which the value to be inserted. So it's straightforward. We have to shift element starting from the last element, and for that I'm going to create a for loop. I'm going to say for I, and remember we have to start shifting from the last, so the value of I will be size, and we'll keep shifting as long as the value of I is greater than index, and the value will be decremented. So I'm going to use the decrement operator, I minus minus, and after that I'm going to come here and say list of I will be assigned the value of list of I minus 1, right? So the index, for example, if the value of I is 4, it gets the value of 3. If the value of the I is 2, it gets the value of index 1, and so on and so forth. So now after we've done this, we are going to insert at that index the new value, which is value, and because we have inserted a new value, I'm going to increment the size by 1. Let's see this. So the current state of our list is that we have values starting from 100, 200, 300, and 400, and let's say at index 1 we want to insert the value 500. So I'm going to say list.insert at 500 index 1, and let's see the list.printlist. Control is to save changes, compile and run the program to see the output. And here is our output. We inserted 500 successfully at index 1 because the first index was 0, which had the value 100. The second index, which is 1, had the value 200, but now it has the value 500. And the magic happens after that. All the rest of the values 200, 300, and 400 have been shifted one spot to the right. So the implementation of the insert is correct. Now let's implement the remove member function, but for that we need to first define the find member function. And the find is going to return the index number. I'm going to call it find. It's going to take a value and it's going to search this value into the list and return the index of that. So it's very straightforward. I'm going to say for int I equals 0, I is less than size, I plus plus. And after that, I'm going to say if the value is equal to list of I, then it means the value is found, return the index of that. And if we don't find, return the minus 1, indicating that the value does not exist because minus 1 cannot be a valid index. So this is the implementation of the find. And now let's implement remove, R-E-M-O-V-E, remove. It's going to take a value that the user wants to remove. So we have to first declare an integer variable called index, a local variable. We are going to call the find member function, which I've just defined above. It's going to take the value we want to find. It's going to return the value, the index of that particular value, and if that index is minus 1, that means the value is not found. So we have to say if index is not equal to minus 1, then we want to remove, because if it is minus 1, then there is nothing to remove. The value does not exist in the list. So how do we remove this? Shifting again. So int I equal to, and then we have to specify that we have to start shifting from the index. I is less than size, and I plus plus. I think I plus plus. Yes. And after that, we have to then say list of I gets the value of list of I plus 1. So we are assigning, for example, if the index, for example, is 2, we will assign the value of index 3 to the index 1, and similarly we'll keep shifting till we reach the end of the list. And once we reach the end of the list, remember we end up with 2 duplicate values, so we are going to put list size minus 1. size -1, the default value of 0, because from the last index we shifted the value to the previous index, and I'm going to decrement the value of size because we have removed a value. So now let's test this, the implementation of this member function. So we are going to come here and say, we added, inserted 500. Now we want to remove it. So list.remove 500. And then we have to print the list to see if the value is removed and shifting has been performed correctly. So run the program. And as you can see, we inserted 500 at index 1. Now we want to remove 500. The remove member function finds the index, which was 1, and then remove that value and shift it 400, 300, and 200 one spot from right to left. So the implementation is absolutely correct. Now let's give it a member function called getSize, which return the size of the list. Get size, and I'm gonna say return the size because size variable is keeping track of the size of the list. So I'm gonna simply come here and test this function with size of the list colon and list.getSize and endl, and let's try this also. And the size should be 4 because there are only 4 elements in the list. So it's correct also. And now an important thing, whenever we are using a dynamic data structure, like in this case we are using the dynamic array, if you go to the constructor, you will see new operator, means memory has been allocated from heap. We want to implement our own destructor. So I'm going to come here and say the syntax for destructor, as you might be familiar with from your course of object-oriented programming, is you put the tilde symbol and then the name of the class, which is my list, and then parentheses, and here just say delete square brackets in the name of the pointer, which is pointing to the first index of the array on the heap, and it's going to signal the operating system deallocate that chunk of memory because I'm no longer needed. So it's going to tell the operating system that deallocate that chunk of memory on the heap. And remember, the destructor will be called once the object that we created goes out of scope. So what is the scope of this object? It's been created in the main function. So if I execute this code and when main function returns, this line will be executed, but we will not see any difference. So let me just display a message and say that the memory has been successfully deallocated from heap. So we'll see this message. The very last message will be this one, I think. So let's run this program and see if it works. And as you can see, when the main returns, we say memory has been successfully deallocated from the heap. So no memory leak in our program. And the last member function I think I talked about was the replace, which is going to replace an existing value with a new value. So I'm going to just about the destructor. You can put your code anywhere you want. I'm going to say void replace. It's going to take 2 values. This time let me call it new value and index at which to insert the new value. And this simple, very, very simple list. And then I'm going to say index, and then I'm going to say new value. So we are not incrementing the value of the size by 1 because we are not inserting, removing anything or adding new to it. The size will remain the same because we are replacing an existing value. I think the implementation is looking good at the moment. So let me just test this. So after the size, I'm gonna list.replace, and we want to replace the value at which index. So we insert 500, then we remove 500, so we are left with 100, 200, and 300, and let's remove the value 300, which is in index 2, 0, 1, 2. So I'm gonna say replace 600, put 6 or 900, and at index 2. And let's print the list again to see the implementation of the replace. And I think you can see that 300 no longer exists in the list because we have replaced that with 900. So we've tested all the functions that we implemented, and this is your complete list implementation using dynamic array. One problem with this list is that the size is fixed because we say the capacity is 5. What if you want to grow its size, if we want to insert more elements, then 5, then this code is going to break. So we will implement vector in the next lecture, and don't forget that because it's super important. Thanks for watching. See you next time.